Hello, everyone. Welcome to the video for looking at the law of conservation of mass. Today, we're going to look at this law, the law of conservation of mass, and first, we're going to go ahead and look at what it means, and then we'll do some sample problems to how we can use it. Okay, so let's go ahead and get started. Let's take a look at right here. We're going to start off with this PowerPoint, and let me see. I'll go ahead and get it going. Okay, so in the chapter that you were assigned to read, chapter 3 in the book, you looked at examples of chemical and physical change, right? So, what is a chemical change? Chemical change is a change that produces matter with a different composition than the original matter. In other words, you put some matter together, or you do something to a piece of matter and it turns into something else. Okay, and we see that a lot. That's basically the basis of chemistry. Right? So chemical changes is really big in chemistry. In chemistry, we generally call these types of chemical changes, we call them chemical reactions. And we write it a certain way so we can kind of see what is occurring. Basically, you start off with some substances that get mixed together, although they're not always more than one substance. Sometimes it's just one substance that you can do something to it, and then they get mixed or they get warmed up, or somehow we get them to change and they turn into something else. What they start off as are known as reactants, chemical reactants, and we write this out by putting the reactants on the left-hand side of what we call a chemical equation. Right? So I have the general form up here of how a chemical equation works. You put the chemical reactants first, whether it be by name, usually it's by chemical formula, as we're going to learn about chemical formulas later on, because it makes most sense. They're more compact, easier to kind of write, but you got to know how to write chemical formulas first. So we're going to start off with just using chemical names, at least at this point in time. So you put the reactants first, then you draw an arrow, and on the other side of the arrow, on the right side of the arrow, are the products. The products are what the reactants turn into. So here's some examples. You can take iron and mix it with oxygen. And see, there are two reactants here, iron and oxygen. And this plus separates out the two reactants. So you put the two things together, they combine and they form a substance called iron oxide. Right? So on the right-hand side of this arrow is iron oxide. We said the product is iron oxide, and the reactants are iron and oxygen. So we can say all kinds of we can say this all kinds of different ways. Iron reacts with oxygen to form iron oxide, or iron oxide is produced from iron mixing with oxygen. However way you want to put it, the idea is you started with iron and oxygen, and eventually you ended up with iron oxide, which has different properties. It has different chemical properties. It has different physical properties than the original iron or oxygen. We also have here aluminum reacting with copper sulfide. Right. Once again, the plus separates out the two reactants. It's going to go to form aluminum sulfide and copper. And the last one, here we go, TNT, which is short for trinitrotoluene. Look at this formula later on in the year. But TNT is the reactant, one reactant, and it basically decomposes, breaks down, and it turns into carbon dioxide, nitrogen, and water. Okay, so these are examples of chemical reactions. And once again, these chemical reactions are examples of chemical changes. Okay. Now, we're looking in today, there's going to be a whole chapter on chemical reactions. I think it's chapter 10 once we get into it. And we'll get there. But today, right now, we're looking at this law of conservation of mass. So we would need to see the relationship between these two things. And a chemical reaction will help us um, kind of see how the law of conservation of mass works. What the law of conservation of mass is stated just here in the first bullet point. Let's read it together. Law of conservation of mass is that mass cannot be created or destroyed in a chemical reaction. It can only change forms. Now, mass, remember, is something that's measured in grams. So if you have the grams of your reactants, they have to equal the grams of the products. And that's what the second bullet point is basically showing. It's a second way of stating the law of conservation of mass. The total mass of the reactants equals the mass of the products. So going back to the previous slide, we see that we have iron and oxygen. So if I were to go ahead and take the grams of iron and the grams of oxygen, add them together, they should equal the grams of the iron oxide because there's only one product in iron oxide. In the second reaction, I have aluminum and copper sulfide are my two reactants. If I take the grams of aluminum that reacted, remember this is only the grams that reacted, and add it to the grams of copper sulfide that reacted, I should get that equal to the grams of aluminum sulfide and the grams of copper that react. So I should be able to add the grams of the aluminum sulfide plus the grams of copper, and those two should equal the grams of aluminum plus copper sulfide. If I were to take the grams of TNT in the third reaction and then take the grams of carbon dioxide, nitrogen, and water that were created from the TNT that decomposed here, adding the grams of these three things should equal the grams of TNT. So whatever's to the left of the arrow, the total grams to the left of the arrow should equal the total grams to the right of the arrow. Okay. Here's some more examples of chemical reactions. I have a whole bunch of them. Iron plus sulfur equals to iron 2 sulfide. So grams of iron plus grams of sulfur, whatever the total mass there, should equal to the grams of iron sulfide. Right? We can pick any one of these. Hydrogen gas plus oxygen gas goes to form water. So take the grams of hydrogen plus the grams of oxygen. That should give you grams of water. So we're going to do a few sample problems and actually calculate a number. We just kind of went over how this whole thing should work. But we're going to go ahead and do some sample problems where we can kind of actually do some calculations. And I'll show you kind of how to do this. Okay, so let's go ahead and do that here in class.